In this video, I thought I'd bring you along as I diagnose what turns out to be a little bit of a weird issue with this 2001 Buick Lesabre. So this car was towed in as a no start. The customer said he'd turn the key and try to start it and nothing would happen at all. There were no dash lights on, nothing like that. Also, he said the headlights were stuck on, so he disconnected the battery. Now, we got the car in the shop, and as you can see in the clip, it starts and runs just fine. To this point, all I have really done is reconnect the battery and then try to start it. It does have some lights on the dash. In that first clip, you can see the voltmeter, or the volt gauge is or the volt light, not gauge, is on the dash, and some of these lights change. I'm gonna restart it here, and you see the check engine light will come on, the security light comes and goes, the airbag light kind of comes and goes, and sometimes the volt light is on, sometimes it is not. Now, the interesting thing is that the volt light is on, but the system is charging properly, which is a little bit of a clue as to what's going on with this vehicle. So the first thing I decided to do is pull out the scan tool and try to pull out any codes from any modules, so I could see if there was anything that pointed me towards the potential problem of an intermittent no start. And what I found was I was not able to communicate with any module on the car. I only showed you one module there, but I checked all of them and I couldn't communicate with any of them. So I decided to pull a wiring diagram of the Class 2 data network on this vehicle. I redrew the diagram into a little bit simpler form. The factory wiring diagram has a lot of things on it that this vehicle does not include. Now, I crossed off the radio there because the radio has been removed from the car. You may have seen it in the other clips. The radio is sitting on the seat. The customer had already removed it. And what I'm going to do next is use jumper wires to connect the data lines as though the radio were there, just to make sure that not having the data lines connected with the radio installed is not causing the issue. Now, if you know anything about how the Class 2 data network works and how this particular one is laid out, you'll know that putting the jumper wires in is likely not going to make any difference at all towards my communication issues. The way this one is laid out is called a ring system, and it only needs one full leg, one wire connecting to each module in order for it to work. So having the radio removed and not having those data lines connected should still allow the other modules on the network to talk properly and communicate with my scan tool. So I knew going into this that this probably was not going to take care of the issue, but I thought I'd do it anyway just to be sure, as it's a relatively easy thing to do. So you can see I struggled a little bit with this connector here, but I got the connector out. I'm going to use a couple of wire piercing probes to poke into the two communications wires, which are going to be purple wires throughout this entire vehicle. And then I'm going to recheck for communications once I have a jumper wire installed to these wire piercing probes. Now, I also want to point out that I did not remove the radio from this vehicle. The customer had it removed already when it came in, along with he had disconnected the battery, so the back seat was up already, and some of the dash panels had been removed. I don't know what the customer was all doing with this vehicle. I don't know if he was trying to solve the problem himself or what the case was there. He did tell me that radio, he had installed it about 3 weeks before this issue had started to occur, and he had removed it thinking that maybe the radio was part of the issue. Now, you see, I removed the backing from the connector. That's to get better access to the wires. One, so I can see the position of the wires, because with a big connector like this, you may have multiple purple wires going to it. I think it turns out that I only have 2 purple wires going to this connector, and those 2 are the ones I need for my communication lines. But you take the backing of the connector off so you can access those wires a little bit better. And then I'm going to take my wire piercing probes, poke them into the wires, and they put a very small hole into the wire, makes contact, allows you to do some testing, very easy, very quick. A lot of people don't like using them. Personally, I don't have an issue with using them. You do need to seal the little holes up with liquid electrical tape or something like that, but you can see me poke those in right here. And then here I'm going to connect the jumper wire. Now this is just one jumper wire with a banana clip end on it, and it's going to connect to both of the leads I put in, and that will complete the circuit so that the communications network is now completed. Now I'm just going to cycle the key on. I'm going to let it run for just a second, then I'm going to start it up and we'll see, and you'll notice that all of the dash lights are still there, the security light's on, the check engine light's not on now. As I said before, that kind of comes and goes along with the security light. And then I'll grab the scan tool and I'm going to go through each of the modules and see if I can communicate with any of them. Now, as I've said, I already knew this was likely not going to work, and it did not work. I am not able to communicate with any of the modules on the vehicle at all at this point. Now what I'm showing you here is I decided to grab the wiring diagram that I drew up and just go through so I could tell where the layout is. Now since the radio is not there, the next one in line is going to be the HVAC module. So I'm going to go ahead and try to communicate with that one. If I can't communicate with that one, which I'm not able to in this case, then I tried the DIM, which is the dash integration module, and that is next in line on the other side of the DLC from the network. When I can't communicate with either of those two modules, I'm also not going to be able to communicate with anything else on the network. Now I don't show it here, but I did check every module once again just to be sure, and I still could not communicate with any of them. So next up is to be grabbing a special tool. This is a DLC breakout box. So one end is going to plug into your DLC. Your scan tool connector can plug into the other end of this breakout box, and this is going to give you a good testing point for each of the pins on the DLC. It's a good way to check for your powers and grounds at the DLC to make sure all that works, and to tap into any communication lines, as you're going to see me do with a digital oscilloscope. The nice thing about these boxes is a lot of them, and this one happens too, you can see the lights flashing, they have those lights. So I already know it has power and ground because the power and ground pins are lit up red and green, and you can see the flashing pin there is the pin for the Class 2 data network on the DLC. Now in this case, what I do first is I grab my meter and I just plug it in there and I check for power and ground at the DLC. I already know they're both there, but I just want to verify that it is battery voltage that's there. And it turns out it is. The battery voltage is good. There's no problems with the wiring coming to the DLC at all. And the next thing I'm going to do is I'm going to move the power wire to the flashing green one, which is for the Class 2 data network. Now it's flashing because something is trying to talk. There's the signal being sent down it. That signal is being sent by my scan tool at the moment. Now you see the meter doesn't read correctly there. So the Class 2 data network works with a 0 to 7 volt network signal. So it's going to be a square wave signal. It's going to pulse from 0 to 7 volts at varying pulse widths. And each of those pulses is a signal being sent out by a module or the scan tool requesting info, something like that. So in order to read it correctly, you need to use a scope. Now here I'm using a Snap-on Zeus scan tool, and that happens to have a scope built into it. So I'm going to hook that up to the scope, and we're going to check the lines to see how good it looks. Now one benefit to using the breakout box is that I have a good ground right there readily available. So I'm going to put the black lead of my scope to the ground at the DLC because it's going to be a good solid ground. And now I'm going to go through and I'm going to set up my scope a little bit. I have my red lead plugged into the Class 2 data line, and I have to go in, set up my scope. You have to get the time base correct and the voltage width correct. So I'm going to set the scope to read DC voltage, and I'm going to set the scale to read a 10 volt scale because I know it's a 0 to 7 volt signal. And then you need to set a time base. Now right off the bat you can see that it is a very, very dirty looking signal. It should be very clean. That bottom line represents ground. It should be nice and smooth, clean line. Each of those signals you see flashing across the screen should be very clean lines that go from 0 up to 7 volts and then back down to 0 almost immediately. You can see this network is an absolute mess, and no network will work when it's like that. Now the next thing to do is look at the wiring diagram, and I'm looking at the PCM specifically. So the PCM is central to the data network opposite the DLC. So here I've removed the PCM and I pulled out those two purple wires. Those are the two communications wires coming into the PCM, and what I'm going to do is cut those. That is going to split the network in half, removing the PCM from the network. This is going to allow me to isolate the problem in the network so I know which side of the network to chase, which modules to go after. So you can see the data line still looks terrible, not clean at all. So the problem is still there, still connected to the data network. Now I'm going to go back and I'm going to look back at the wiring diagram, and I'm going to show you which 4 modules that problem resides in. So here you can see on the wiring diagram, I have removed the PCM from the equation and I've removed the radio. So that whole half of the network is no longer connected to the DLC. So my problem is either with the ABS, the rear integration module, or the airbag module, or the dash integration module. Now I decided right away to go towards the dash integration module, as that's one of the easier modules to access, and it's located behind the rear seat. Now when I pulled the rear seat off, I showed you the burn mark right there. When I went to pull that seat back off, the car started smoking like crazy. I was getting smoke from the wires, and you can see here where the wires are pinched and have rubbed up against that, and you can see it's all melted. Now there are 2 data lines that run into that harness to go down to the dash integration module. So I need to start by repairing those wires. Here you can see I've opened them up and I can show you, just showing you the melted areas there. Now I don't really know how they rubbed through. I just know when I went to remove it, they started smoking. I had to disconnect the battery quickly for an electrical fire, and I can cut all of those out now and go ahead and repair it. So here you see I've repaired all of those wires, and I've got the battery hooked back up. And now where's things got a little bit more interesting. Now as I climb back in front, the first thing I do is look at the scope, and you can see that scope signal is very nice and clean. There's the ground, it looks really good, really nice. And then I go and I try to start the car, and you notice I turn the key and nothing happens. The dash doesn't light up, the car won't start, nothing will happen. The one thing I didn't show is as I was hooking up the battery, every time I tried to hook it up, the horn started honking and I couldn't get it to stop. So I actually had to get out and remove the horn relay, and my driving lights were also stuck on. So I had to remove the fuse to get the driving lights to shut off as well. A little bit weird. I go and I recheck for communications, and you can see I'm now using a Autel scan tool instead of the Snap-on scan tool. Now the reason I switched to the Autel scan tool is because I went, in the process of diagnosing this car, I went to diagnose another car, and my Snap-on scan tool was not communicating with any of the modules on this other car either. So I switched to the Autel to make sure that my Snap-on scan tool wasn't giving me any issues. Now you can see that I do not communicate with many of the modules on the car, but I do communicate with some of them, and there's code setting in them. Now the reason I'm not communicating with all of them is actually because they need the ignition to turn on. So I'm not communicating with the PCM or the ABS, the airbag module, or I believe the dash integration module. Those are all offline because they need to be turned on by the ignition switch being turned on. But the other modules on the car are talking. You can see a nice clean data signal there, the 0 to 7 volts, that all looks good. They look a little bit jagged, and that is simply because of the sample rate of this scope isn't the best, which is why the lines look a little bit jagged. It just doesn't catch it when it comes all the way up to that 7-volt signal. So now I'm going to be honest, I probably spent way too much time scratching my head at this point. I cut out a lot of it, but it took me a little while to come up with a plan. But I figured since a lot of things weren't turning on, nothing was working, I had to check to see if my ignition switch was maybe the fault. See, this right here is actually the problem that the customer told me he was having in the first place, where nothing would turn on. So you can see here, I'm just removing all of the panels. I'm going to remove the lower cover from the steering column so I can access the back of the ignition switch, and just check to see if I have power going into the ignition switch and power going out of it. Now in hindsight, I probably should have gone and checked the fuse before I did any of this, because I didn't think to do that, but things were a little hectic. I was doing a lot of different stuff at one time, and I decided I was going to go here. Because things worked originally, I didn't suspect that there was going to be a lack of power coming to the ignition switch. I kind of assumed my problem was going to be that power wasn't coming out of the ignition switch. So now that I have these covers off, I can show you what I did here. Basically, I found the wires that I needed, and I pierced them with the wire piercing probe, and I'm just going to check for power. Now, this first wire I checked is the power coming into the ignition switch from the ignition switch fuse. So I put the wire piercing probe in, I'm going to hook up my jumper wire and connect that to my multimeter. And you're going to see that there is no power coming into this. So I have nothing. I should have battery voltage right there. There's nothing coming into it whatsoever. So I go back, I look at the wiring diagram, and there's an ignition, there's a fuse there. It's in the fuse box right next to the battery under the back seat. And I'm just going to use a test light to touch the top of the fuse to see if it lights on both sides of the fuse. If it only lights on one side of the fuse, that means the fuse is blown. It's a little bit easier than pulling the fuse out and putting it back in and all of that. This is just a little bit quicker. So you can see it works on one side of the fuse and it does not light on the other side of the fuse. So that fuse is blown. My guess is it probably blew when the wires shorted out when I tried to remove that back seat. So what I do is I grab a new fuse, I stick it in there, and recheck to see if everything works properly. So I put the new fuse in, and you can see that the light now lights on both sides of the fuse, so the new fuse didn't blow when I put it in. Now the next thing I need to do is get out, go back to the front of the car, turn the key on, see if the engine starts, see if the dash works, all of that stuff. So now you can see here that the dash lights up, everything works good. It takes me a couple of attempts to get the vehicle to start and run, but it does start and run. It died a few times on me. I think it has a issue with the fuel pressure bleeding back from the pump, but once you get it going, it works good. No lights are on the dash now. And what I'm going to do now is I'm going to grab the scan tool and I'm going to rerun the auto scan to see if all of the modules are talking and what codes are set and all of that. So you can see that the scan tool now is able to talk to every single one of the modules. There was a bunch of codes that set, and I didn't think I showed you what all the codes were. Basically all of the codes set are caused by communication issues and the battery being disconnected and that thing. So I cleared them all out and nothing comes back. There's one code that I'm going to show you that does come back, and that is simply because I have the headlight switch unhooked. The customer mentioned that his headlights were stuck on, and it was actually a result of the headlight switch being stuck. You had to pry the button out with a screwdriver, so we put a new headlight switch in, and that is the only code that comes back in the system. Now I mentioned too that when I hooked the battery up, the horn started honking and the daytime running lamps are stuck on. So I'm going to put the relay back in, the horn no longer honks, and when I put the fuse back in for the daytime running lamps, those are all turned off now as well. Everything's working good and there are no more issues with this vehicle. So really quick, while I'm going through right here and just doing my final checks in the car, I'm going to run one final scan after I put everything together, just to make sure that everything's good. When I run that scan, you're going to see one fault pop up in one of the modules, and that's simply because I just haven't plugged in the new headlight switch yet. But other than that, everything was good. It really just came down to that wiring harness being shorted out. I did a little bit of research because I never did get it to not start other than when that fuse was blown, and that fuse was not blown when it came in. design. That was a result of the wire harness shorting out when I removed the back seat. I did a little research, and it's relatively common to see a vehicle, to see these specifically not start when they have intermittent communication issues where the harness is shorted out like this. Relatively common, so that was the cause of his no start issue, and it hasn't been back. He hasn't had an issue with it since I looked at it. I really hope you guys enjoyed watching this, and maybe you learned something watching the diagnostics and kind of how the process works. This was a long process, in a 20-minute video or so. This was really a few hours worth of diagnostics, probably three hours or so worth of diagnostics and wiring repair and things like that. But I really hope you guys enjoyed it, and that'll be it. Thank you guys for watching.